Welcome to my YouTube channel Knowledge Entertainment, and once again we are here with the topic of complex numbers and quadratic equations. So we will solve some more questions today on the topic. Before moving ahead, I'll like to request you to subscribe my channel, to share my videos with needy 10+1 students who cannot afford for coaching or for other sources. So here we start with some more questions. In the previous video we have seen some easy questions, and now we'll move on to a little bit, only a little bit difficult questions, not too much. So what the questions I'm going to take today? The first one is solve for z. Solve for z. This equation is 2 plus iota z is equal to 3 minus iota. So how to solve this equation? This equation can be solved in several ways. So I am going to solve this equation in two different methods. So first method, let z be your complex number x plus iota y. Substitute the value of z over here. You will get 2 plus iota x plus iota y is equal to 3 minus iota. And now open this bracket, multiply these two. So what you are going to get, 2 into x is 2x, and this iota into iota y is iota square y, but iota square is equal to -1, so it will become minus y. So these are two terms without iota, and now there are two terms. This term iota x, imaginary part, and this term 2 iota y is also imaginary part. So take iota common. What you are going from here, x plus from here 2y is equal to, on the right side you are having 3 minus iota. Now equate real and imaginary parts from both sides. On the left hand side the real part is 2x minus y, so it is equal to the real part of the right hand side, that is 3, and imaginary part of the left hand side is x plus 2y is equal to imaginary part on the right hand side is -1. Now we have to just simplify these two equations, multiply the first equation by 2 and then add. What you will get, 2x into 2 is 4x and plus x. 4x plus x is 5x. Here you will get minus 2y, and this is plus 2y will be cancelled out, so is equal to, on the other side, 2 into 3 is 6 and -1 is 5, so your x comes out to be equal to 1. Now substitute this value of x is equal to 1 in any of these two equations to get y. So let us take the second equation, put x is equal to 1, you will get 1 plus 2y is equal to -1. So 2y is equal to -2. This means your y is -1. Your x is 1, your y is -1. So what is your z? Your z is 1 minus iota. 1 plus iota into -1. So 1 minus iota. This is one method. So you can adopt other methods. Another method which I am going to use here to solve this equation. So take this 2 plus iota to the right hand side. You will get z is equal to 3 minus iota over 2 plus iota. And now multiply denominator and numerator on the right hand side by 2 minus iota. So your z will be equal to, in the numerator multiply 3 into 2 is 6, 3 into minus iota is -3 iota, minus iota into 2 is -2 iota, and minus iota into minus iota is plus iota square, but value of iota square is -1, so it will become -1. In the denominator you are having a plus b into a minus b, and a plus b into a minus b, we know that it is equal to a square minus b square, so it is 2 square minus iota square. Now what you are going to get, this 6 minus 1 is 5, minus 3 iota minus 2 iota is minus 5 iota. In the denominator, this minus iota square means plus 1. And 2 square plus 1 is now 5. 5 is also common from the numerator. You can take 5 common and will be cancelled out with this 5 of the denominator, and you will get 1 minus iota as the answer for Z. So you can solve Z in several ways. 2 methods I have discussed here. There are several other methods by which you can solve this equation to get the value of Z. So now I'll move on to another question. As I have said, I'm not going to very difficult questions. Just we have started this topic, so we will move on to the tricky, typical questions slowly and gradually. So next question, once again, I'm going to take not too difficult. Once again, another easy question, and the question is find the value of lambda from 1 plus lambda iota into Z is equal to lambda plus 4 iota, given that Z is purely real. That means the imaginary part of Z is equal to 0. So there are once again several methods, but I'm not going to use 2 or 3 or 4 methods again and again. So I'll solve it by one method, and it will be an exercise for you to solve it by other methods. So what is the simple solution, simple way to solve this equation? Take this 1 plus lambda iota to the right hand side in the denominator. So you will get your Z is equal to lambda plus 4 iota over 1 plus lambda iota. Once again, multiply the numerator and denominator by 1 minus lambda iota. Now multiplying, what you are going to get? In the numerator, this lambda into 1 is lambda, and this 4 iota into minus lambda iota is minus 4 lambda iota square. But since iota square assumes the value equal to minus 1, so the product of these two will become plus 4 lambda. And when you will multiply, erasing it, when you will multiply this, when you will multiply first with the last and second with the third, you will get imaginary parts. So iota will be common, and from here you will get 4. From here you will get minus lambda square and divided by, in the denominator once again it is a plus b into a minus b. So a square minus b square. A square is 1 square is 1, and minus b square. B square is lambda square iota square. But once again iota square is equal to minus 1, so it becomes plus lambda square. Write this number as, this is your 5 lambda over 1 plus lambda square, and then plus 4 minus lambda square over 1 plus lambda square iota. So this is your Z now. But what you are given that your Z is purely real. And Z is purely real means its imaginary part is equal to 0. And here your imaginary part is this. So substitute the value of imaginary part 4 minus lambda square upon 1 minus lambda square is equal to 0. And a fraction is 0 if its numerator is 0. So you will get 4 minus lambda square is equal to 0, which will give you two values of lambda as plus minus 2. So for these two values of lambda, your Z will be purely real. So this was the second question of the day, and now we'll move on to another question, the third question, which is once again not too tricky. We will almost take all the questions easy once again today, so that you may be handy with these questions to handle tricky questions later on. The next question I'm going to take, the question is find values of x and y if x 1 plus iota square plus y 2 minus iota square is equal to 3 plus 10 iota. It is another easy question, not difficult, and solution is almost on the same lines which we used for the solution of the first question today. So first of all, open these squares. This is x here, and when you open this bracket you will get 1 plus iota square plus 2 iota plus y into, open this square, you will get 4 plus iota square minus 4 iota. On the right hand side you are having 3 plus 10 iota. Now simplify further. So what you are going to get, x into this iota square assumes the value minus 1, and here you are having plus 1. So this plus 1 and minus 1 will be cancelled out. You will be left with 2 iota x. So first term is 2 iota x. Secondly, this iota square is once again minus 1. 4 minus 1 will become equal to 3. And open the bracket now, plus 3y minus 4y iota is equal to 3 plus 10 iota. Now on the left hand side, the only real part is 3y. So this 3y is equal to, on the right hand side, real part. The right hand side real part is 3. So 3y is equal to 3, which means y is equal to 1. Now equate real imaginary parts both sides. On the left hand side, your imaginary part includes 2x minus 4y. So 2x minus 4y is equal to, imaginary part on the right hand side is equal to 10. You can substitute the value of y is equal to 1 here to find the value of x. So substitute y is equal to 1. Your 2x minus 4 into 1 is equal to 10. 2x is equal to 14. So x is equal to 7. So what your final solution is, your x is equal to 7 and your y is equal to 1. These are the values of x and y which will satisfy the given equation. So this was another question, another easy question, and we will solve more and more questions so that you may feel it easy to handle the tricky questions later on. One more easy question I am going to solve here. Solve for z. Solve for z. And the equation given is 4z minus 3z bar is equal to 1 minus 18 iota over 2 minus iota. Here, what is z bar? Z bar is the complex conjugate of z. So, taking z is equal to x plus iota y, our z bar will become x minus iota y. So, solution will start now. Let z be x plus iota y. This automatically means z bar is x minus iota y. And now substitute the values here in this equation. So 4 x plus iota y minus 3 x minus iota y is equal to, on the right hand side, as we have solved in the previous cases, multiply the denominator and numerator by 2 plus iota, or you can say rationalizing process. On the left hand side, the first term is 4x, the third one is minus 3x. These are the real parts, and for the imaginary parts, look at these two. So this is plus 4 iota y plus 3 iota y is equal to, on the other side I am going to multiply. 1 into 2 is 2, 1 into iota is plus iota, minus 18 iota into 2 is minus 36 iota, and finally minus 18 iota into iota is minus 18 iota square. But using iota square, is equal to minus 1, it becomes plus 18 divided by, it is a minus b into a plus b, that means a square minus b square. A square is 2 square means 4 minus b square is iota square, but iota square has the value minus 1, so it will become plus 1. Now this 4x minus 3x is x, plus 4 iota y plus 3 iota y is 7 iota y, is equal to this 2 plus 18 is 20, and this minus 36 iota plus iota is minus 35 iota, divided by 5. 5 can be taken out from the numerator and can be cancelled out with the 5 of the denominator to give the result 4 minus 7 iota. And now the question is very easy. You are just to equate real and imaginary parts on both sides. Equating real parts both sides, you will get x is equal to 4, and equating imaginary parts on both sides, your 7y will be equal to minus 7, which means y is equal to minus 1. So this way you can solve such an easy question once again. And there are several questions, and we will solve more and more questions so that it will be easy for you to solve questions, typical questions later on. Another question is, find square root of 21 minus 20 iota. Now, one thing is clear, if a complex number has imaginary part in negative, its square root will also have imaginary part in negative. If it has imaginary part in positive, its square root also has imaginary part in positive. So, we assume that let square root of this number be x minus iota y. I have taken here minus because the number itself is having negative imaginary part. So its square root will also have negative imaginary part. Now squaring both sides, what you will get? The left hand side is very easy, it's 21 minus 20 iota. On the right hand side, when you square it, you will get x square. This minus iota square y square will become plus y square, and minus 2 iota xy. Equating real and imaginary parts once again. The real part on the right hand side is x square plus y square is equal to, on the left hand side is 20, and when you will equate imaginary parts, here you will get 2xy is equal to 20, minus 2xy is equal to minus 20, minus will be cancelled, 2 will also be cancelled to give xy is equal to 10. Now we know a common identity that x square minus y square is equal to square root of x square plus y square whole square minus 4x square y square. So substituting the values here, it is square root of this x square plus y square is equal to 21, and square of 21 is 441 minus this is 4x square y square. So it is 4 and xy square, that means 10 square. So you are having square root 441 minus 400. So it is square root of 41. This is the value of x square minus y square. Now you know the value of x square plus y square. You know the value of x square minus y square. Adding them, you can get the value of x, and subtracting, you can get the value of y. Substituting the values of x and y here, you can easily find the square root of the given number 21 minus 20 iota. Now I'll consider more questions to make the practice more and more easy. The next question I'm going to take is, the question is, solve the cubic 2z cube minus 5z square plus az minus 5 is equal to 0 given one of its roots is 2 one of its roots is 1 minus 2 iota. Also find value of a. Also find value of a. This is the question. Here one thing is to be noted, that this equation, this cubic equation, is having all the coefficients real. This a is also given to be real. We are given that also find real value of a, you can say. Also find real value of. So a is real. First coefficient 2, second minus 5, third a, fourth minus 5. So all the coefficients of real are real. And if a polynomial equation has all the coefficients real, then its complex roots always occur in conjugate pairs. So if one root is given to be 1 minus 2 iota, another root must be 1 plus 2 iota. So since coefficients are all real, therefore complex roots must occur in conjugate pairs. Given z is equal to 1 minus 2 iota is a root, therefore its complex conjugate z bar 1 plus 2 iota is also a root of this equation. Therefore you can find a factor of this equation, and the factor, therefore z minus the first number minus 1 plus 2 iota into z minus the second number minus 1 minus 2 iota is a factor of given equation. Now simplify it. It is a plus b and a minus b. So a plus b into a minus b is a square minus b square. So it is z minus 1 whole square minus 4 iota square is a factor of this equation. Simplify it further. So it is z square minus 2z plus 1, and it will become plus 4. That means you can say 5 is a factor of this equation. Now you can factorize the given equation. You are having one factor. Let us see what will be the other factor. It's very easy. It's just your given equation is 2z cube minus 5z square plus az minus 5, and one of the factors is z square minus 2z plus 5. This equation is a cubic. One of the factors is a quadratic. Definitely the other one will be linear. So let it be mz plus n. Just equating the coefficients of z cube and constant term, we can find the values of m and n. Here the coefficient of z cube is 2, and here the coefficient of z cube will be m. So the value of m is equal to 2. Similarly, the constant term here is minus 5, and here the constant term is 5n. So 5n is equal to minus 5 means n is equal to minus 1. So you are getting the third factor also. So third factor is 2z minus 1. Therefore, all the three roots are first was given 1 minus 2 iota, second by inspection was 1 plus 2 iota, and the third one from this factor is 1 by 2. So all the three roots are there. Now we are also to find the value of a. To find the value of a, what you have to do, just equate the coefficients of z from both sides. Here the coefficient of z is a. On the other side you will get z when you will multiply these two terms. So minus 2z into minus 1 is 2, and 5 into 2z is plus 10. So it is 12. The value of a is 12. So here I am going to stop this video. Once again we will be there in the upcoming video with more and more questions on complex numbers and quadratic equations. Before leaving, I request you to like my video, to share my video with your plus one friends and subscribe my channel. Thank you once again.